Okay, having discussed group 7 elements na the introductory lecture, let's look into their chemical properties in this lesson. And starting with hydrogen, chlorine, it's explosive when it's reacted in hydrogen, given in darkness. It can see reactant H2, and this will reaction can result in the formation of the hydrogen fluoride. Chlorine too explodes with hydrogen, but this requires heating and it prayers of EPY. So when darkens because the UV light, this reaction basically doesn't take place. Once you expose to the once you expose to heat and sunlight, the chlorine can explode hydrogen in the hydrogen chloride gas. Yeah, still on the absolute. How hydrogen? Hydrogen and bromine can react with hydrogen still and this will require heat. However, indeed, unlike chlorine and bromine that can explode, this turbine requires catalyst, and this catalyst is platinum, and it requires a heat of 1 Celsius per. Now it's like formation of our hydrogen bromide. Iodine requires still a platinum catalyst, but the occurs at the temperature of 400 degrees Celsius from the hydrogen iodide gas. All these these hydrogen halides of these the hydrogen halides here are all in gaseous state, as you can see. Looking into the second properties, the second reaction, which is with water. Chlorine is vigorous when it's reacted in water to form oxygen or ozone and hydrochloric acid, as we can see in our reaction right here. And then chlorine can disproportionate in water to form the chloric 1 acid and hydrochloric acid. Bromine too disproportionate, just like chlorine, to form the bromic 1 acid and hydrochloric acid in water. Iodine never reacts with water under all circumstances. Let's look at the bromine that can disproportionate just like chlorine into bromic 1 acid and hydrochloric acid in water. And let's explain why iodine does not react with water. One, iodine is a non-polar, while water itself is polar. So we are seeing two different characteristics that the polar and non-polar, just like the principle of dissolution is that like dissolve in like, meaning non-polar dissolve in non-polar and polar dissolve in polar. But further explanation is that the intermolecular forces of attraction in these individual molecules of iodine. Let's look at this. That iodine, the intermolecular forces of interaction between iodine and let's say water here, on average, are stronger. Meaning the interaction between iodine and iodine ions are quite stronger and individually, and that interaction between the hydrogen ions and oxygen in water are stronger compared to when they actually mix together. So this results to some kind of form of repulsion, absorption, making, and the interaction when they are or dissolved in one. However, there is potassium iodide that can dissolve this iodine, and it will form the complex of potassium iodide as indicated in the equation below. Let's look at a reaction with sodium hydroxide. We are studying in the cold and dilute sodium hydroxide. Basically, fluorine can react with the cold sodium hydroxide and perform the sodium bichloride, chloride, these chloride ions, and water. Below is the equation for the reactions and both ionic and ionic reactions. So either way, the you write ionic or non-ionic, it's still correct. But basically, fluoride, fluorine, ions, and then water as the products of this reaction with sodium hydroxide. And chlorine in cold sodium hydroxide will disproportionate chloride with disproportionate. This means it breaks down into different molecules, which forms the chloride 1 ions, the fluoride ions, and water molecules for this case. You can either write this ionic equation or the molecular or the ionic equation. Bromine also disproportionate, just like chlorine, from the bromide 1 ions and the bromide ions and water. Iodine still happens in the same way. So that's basically the reaction for the matter of bromine, and the iodine too goes through the same reaction to form the iodate 1 ions, iodate ions, and water. Chloride 1 ions and bromide 1 ions that are formed can undergo further disproportionation. But this occurs when it is heated and will form the chloride 5 ions and chloride ions. Then the bromide 5 ions and bromide ions respectively for chloride 1 and bromide 1 ion. You can see a color change that will take place here at the yellow solid will turn to be colorless after this reaction taking place. This is ionic for chlorine and then the chlorine. They indicate this reaction will progress into this color change. However, in concentrated sodium hydroxide, chlorine reacts with hot concentrated hydroxide and forms oxygen and chloride ions and then water. And in chlorine, this can result into formation of the chloride ions and chloride 5 ions and water. As its products due to the disproportionation reactions, just like the equation that we have talked about. Same reactions occurs for iodine and bromine. So what's unique in reaction secreted for sodium hydroxide here is only the chlorine ions that forms of chloride ions and water with oxygen. But the rest of the halogens, they form their halide ions halide 5 ions in water. Just which is in iodine and bromine plus chlorine. Let's look at oxidation actions of these molecules or the solvents. One, this will help us to go through with some observation. Let's try to explain this through some observation that we can make. As I said, the observation and explain when chlorine and bromine are added separately to iron. Two, what basically happens here is that when you bubble this bromine and chlorine, when they are added, they are used up oxidizing agents, meaning for this matter, the iron 2 would be oxidized into iron ferric, and the chlorine will be used into chloride ions. And the similar reactions occurs with the similar reaction occurs with bromine. Basically, for observation here, you see that this gas is said the greenish yellow. This greenish gas, which is chlorine, dissolves, and in a solution of iron 2, this solution will actually equine and ions. So the color change here is that it should change from green to brown, iron 3 ions. So that's basically an observation that you can have there. Let's see that chlorine, when it's bubbled through a solution of potassium nitrate and silver nitrates, followed by ammonia, and then you add to the resultant solution. What happens? Observation, this greenish yellow gas will dissolve on some colorless cold solution and white PPT. That is in excess ammonia. So when you add in ammonia, these solutions become red sulfur and form a colorless solution. But upon adding that, you will have a white precipitate, and in excess of ammonia, you will form the colorless solution. Let's look at any poison to explain this observation. That chlorine will oxidize the nitrate ions to nitride ions, and itself will be reduced to chloride ions. Let's take a look at these nitride ions. Okay. Let's look at closely at what happens right here. These are the nitride ions. When reacted with chlorine, what basically happens here is that the chlorine, as an oxidizing agent, will oxidize these nitrate to nitrate ions, which is the end of getting, and then itself will be reduced into chloride ions. And this basically forms the white. But upon adding in excess, these silver ions, the silver ion, we saw before that the silver nitrate that is also in that same solution. Also, the silver ions will react with the chloride ions to form silver fluoride. That's so, which is very insoluble, and you happen to see silver chloride, which is now the insoluble white precipitate. How are this silver chloride? When you react it with excess ammonia, it will form a soluble complex of diamine silver ion ions. Now, that gives an explanation as to why this observation was is that the greenish yellow gas, which is chlorine, dissolved in the solution. So that resulted into the formation of the nitrogen ions because of the reduction reaction. And this reaction still continued where these chloride ions that has been formed through the oxidation of this nitrate from potassium reacts with the silver ions, which is from the silver nitrate, forming our silver chloride. This gives us the white precipitate that we have seen. So this is very soluble. But upon addition of ammonia solution, it will result into the formation of our complex. And this is very soluble. That's why we have at the end of it a colorless solution. So our complex here is the diamide silver 1 ions. That's basically an explanation for that. But we can see that there is more oxidation reactions that can take place with the sodium thiosulfate and hydrogen sulfide, sulfuric acid, and in different realms also is. So that's basically the end of our lesson on the chemical properties.